Okay, so the idea now is to talk about mechanical ventilation basic modes. We have two basic modes. We have the volume control mode, which gives breath to the patient based on the volume we dedicate to the ventilator. And we have the pressure control ventilation, which based on the idea that we give a pressure that the ventilator should get to, and we don't know the volume that the machine will give. We need to adjust the pressure in order to get a certain volume. So volume control ventilation, VC, I'm talking about assist control ventilation, which means that the ventilator gives breath to the patient that are mandatory. Volume control ventilation says that the machine, the ventilator, will give breath to the patient based on the volume we will give to the machine, to the ventilator. You see that the key parameters that we can set in volume control ventilation are the tidal volume. Namely, I set the tidal volume for the patient, the volume that the machine will give to the patient on each breath, which is usually for an adult male around 500 milliliters, 600 milliliters. You see that it can be 6 to 8 milliliters per kilogram for ideal body weight, not the weight of the patient, but ideal body weight. We can set in volume control ventilation the respiratory rate, what is the rate in which the patient or the machine will give the uh, ventilations. You see that it's a RR, which is 12 to 20 breaths per minute. I can set the flow rate, which should be around 40 to 60 liters per minute. I can set how much oxygen, what is the percentage of oxygen in the breath I give to the patient, should be around 21 to 100%. The positive end expiratory pressure, PEEP, which should be around 5 centimeter of water, depends on what is the pathology. In COPD, maybe a little less, and in ARDS maybe on the upper limit. But PEEP, positive end expiratory pressure, what it does in the end of expirium, the end of exhalation of the patient, we want the alveoli to stay a little bit open with a little bit of pressure. This is the pressure that the alveoli will be opened even in the end of expiration in order to prevent atelectasis, in order to prevent the alveoli to collapse. So we give a little bit of pressure such that the alveoli will keep open, so the ventilation will be better. This is the PEEP. This is the idea of the positive end expiratory pressure. We set it around 5 to 10 centimeters of water. You see that also in the pressure control ventilation, we also have the PEEP set around the same. Now, in the volume control ventilation, I cannot set the peak inspiratory pressure, which should be no higher than 30 or 40 centimeter of water, not higher than this. I need to monitor this. I give the volume that the machine, the ventilator will give, and I need to see what the pressure it gets to. I don't want the pressure to be too high, so because if it will be too high, more than 30, 40 centimeter of water, there may be barotrauma, there may be pneumothorax. So I need to see that the pressure is not too high. And in volume control, I cannot set the pressure, I need to monitor it. This is the volume control ventilation. This is one of the basic ways to ventilate a patient. Very, very common volume control ventilation. Now, the pressure control ventilation, as we said, we adjust the pressure, and by the pressure, the volume that the patient will get needs to be monitored because I don't know what the volume will be, but I know what the pressure will be. I set the inspiratory pressure for the patient, for example, between 15 to 25 centimeters of water. I set this pressure, so I know that this is the limit. The patient won't have higher than that pressure. Of course, by that, I can prevent barotrauma to the lungs. I can reduce the risk for barotrauma because I control the pressure. and I can prevent pneumothorax in a very non-compliant lungs, because in a very non-compliant lung, think about it, I can give pressure such that for any other normal patient, this volume will be okay, but in particular patient with very stiff lungs, this little volume will get us to a very high pressure. So in pressure control, I know what the pressure will be, and based on that pressure, according to the lungs of the patient, the volume will be. It can be high, it can be low, I don't know. I need to monitor the tidal volume that the patient will get. So I can set the inspiratory pressure. I can set the RR, the respiratory rate, like in volume control, how many breaths per minute the patient will get. I can set the inspiratory time. What is the time that the patient will breathe in? It's around 0.8 to 1.2. We want a ratio between the inspiratory to expiratory around 1 to 2, 1 to 3, in COPD or asthma even 1 to 4, more of expirium because the patient need to exhale. Exhalation should be usually longer than inspiration. FiO2 again, it's the percentage of oxygen in the air I give the patient, and PEEP, as we said, positive end expiratory pressure, again, what the pressure will stay in the alveoli, in the lung, in the end of expirium, in the end of the exhalation of the patient, such that the alveoli won't collapse, prevent atelectasis, better ventilation, but know that too high PEEP can cause barotrauma, can cause too high pressure and pressure on the veins like the vena cava and reduce the overload if the PEEP is too high. So note for hypotension if the PEEP is high, but PEEP helps you ventilate the patient. And of course, in pressure control, I set the pressure, but I need to monitor how much volume the patient will get. I don't know. It depends on the lungs of the patient, what volume the patient will get by that pressure for the specific lungs and compliance of the lungs of this patient. So this is, those are the basic two modes for mechanical ventilation. The volume control ventilation, we give the volume, we don't know the pressure, we need to monitor it. And the pressure control ventilation, we give the pressure, we need to monitor what the volume of the patient will get. Volume control and pressure control ventilations, those are the two basics modes of mechanical ventilation. Thank you very much. And that's it. Thanks for JGPT for creating me those diagrams. That's all. If there are any mistakes or corrections, please tell me. And that's it.